Good evening all. Myself and Arun Kumar from EC department. In this video, we are going to see modeling of electrical systems. So, whenever we are going to operate in a control elements, these are all some essential factor while considering a control system modeling. In a system, it can be classified by several factors, especially for frequency domain and time domain, hybrid domain. So based on these three domains, the signal can operate from source to destination. In this case, so these things can be happen by using the system function. So initially, we have to consider an experiment model of the system. The experiment model, either it may be a physical model or a mathematical model. If it is a mathematical model, we are going to take it as a simulation. Before that, we are going to analyze the particular concept of the mathematical expressions. After that, we can move towards the simulation process. The simulation has been established by using three factors, either frequency domain or time domain or hybrid domain, because we are going to analyze the system functioning, system of the corresponding transfer function. So we can able to calculate by using the three parameters. Next one is type of systems. Either it may be static or dynamic system. Static means it's a constant. Dynamic means it's a variations. Dynamic systems. So moving mass. While considering electrical equipments, we are going to see how the electrical equipments or the signal has moved towards the end. While moving towards the some functions, we are going to take it as a force. The force is nothing but mass into acceleration. Mass into acceleration. Based on the mass into acceleration only, the system can move towards the destination with the help of force. Next one is some of the basic elements of electrical system has been assigned for control systems. For capacitor, we can capacitor and resistor. We have to while considering a resistor. So some of the current can be flow towards the resistor. So the current can be identified and written by using the voltage by V R of T equal to I into R, T into resistor, R into I into V equal to IR. So the same formula can be applied. While considering this elements of electrical system, we have to write like this: IR of T into R. So likewise, the capacitor also calculated. So these are all some fundamentals while writing an electrical systems. Vc of T capacitor across the voltage. T equal to 1 by C because it's a capacitor. So 1 by C. Whenever we have written the capacitor, whenever we have considered the capacitor, we have to write integration part because it's a fundamental properties of the capacitor while in electrical systems. So 1 by C integration of IC capacitor into T into dt. So after considering a Laplace transformation, the above equation can be rewritten by 1 by Cs ICS. Next for inductors. So inductor, while writing the inductor, we have to consider differentiation part because it's a fundamental properties of the inductor. So inductor equal to L into di L of t into dt. While considering Laplace transformation, the above equation can be written as L into S IL S. So these are all some possible combination of voltage to current and current to voltage relationship. Because whenever we have considered the circuit, we have to take part as a two parts. Either it may be current or voltage. If it is voltage, we have to take resistor like the above formulas. Whenever we have considered current to voltage relationship, we have to take this formulas. For example, if we are going to consider a capacitor, so in this case for voltage to current regulation, the capacitor, the voltage across the capacitor will be 1 by C integration of IC dt into dt. But in this current to voltage regulation, the value may be changed as a differentiation because we are going to calculate the capacitor across the voltage in this case, but in I to voltage current across the capacitor. So we have to write C into dVc by dt. So the integration part can be replaced by differentiation part. So these are some basic properties of the voltage to current and current to voltage regulation while considering parameters like resistor, capacitor and inductors. So examples, let us consider example of open loop circuit. Initially the voltage will be passed towards the input circuit. A resistor can be connected across the capacitor. Then we will get the output of the corresponding signals. The input voltage can be calculated by VIT because it is going towards the loop. So current can be passed towards the loop. So I of t into R plus, already we have discussed about the concerned properties of the capacitor while considering a capacitor across the voltage is 1 by C integration of I of t into dt. And then output will be calculated by the output terminals can be connected with the help of capacitor. So we have to consider only the capacitor across the voltage. So the output voltage becomes 1 by C integration of I of t into dt. So thank you.